Hello students, welcome back to Akgec's channel. Today we will be taking the fourth lecture of Big Data and we will be studying about Introduction to NoSQL. NoSQL stands for Not Only SQL, meaning that NoSQL databases have the specificity of not being relational because they can store data in an unstructured format. NoSQL databases have become popular in the industry because of the following benefits. Number one is multi-mode data. NoSQL databases offer more flexibility than traditional SQL databases because they can store structured example data captured from sensors, unstructured images, videos, etc. and semi-structured XML, JSON data, etc. Now it is also easily scalable. This is made simple because of their peer-to-peer architectures, meaning multiple machines can be added to the architecture. Global availability. This allows access to the same data simultaneously through different machines from different geographical zones because the database is shared globally. Flexibility. NoSQL databases can rapidly adapt to changing requirements with frequent updates and new features. Now, what are the features of NoSQL? First of all, it is high scalability. NoSQL databases can handle increasing demand by adding more servers to the infrastructure. High availability. They can run continuously without interruption of services. Efficient big data management. NoSQL database have a storage capacity of a large amount of unstructured data, making them good fits for big data. Partition tolerance. They continue to operate even in case of unavailable network connection between nodes. Fast development. They are adapted to the fast changing agile environment which needs constant feedbacks and fast iterations. And of course, high availability. They can run continuously without interruption of service. Now, let's study about the differences between NoSQL database and SQL databases. Now, first of all, language. SQL databases use structured query language to perform operations requiring the use of predefined schema to better interact with the data. While on the other hand, NoSQL databases use a dynamic schema to query data. Also, some NoSQL databases use SQL-like syntax for document manipulation. SQL databases have a predefined and fixed format which cannot be changed for new data. NoSQL databases are more flexible. This flexibility means that records in the databases can be created without having a predefined structure, and each record has its own structure. SQL databases are only vertically scalable, meaning that a single machine needs to increase CPU, RAM, SSD at a certain level to meet the demand. NoSQL databases are horizontally scalable, meaning that additional machines are added to existing infrastructures to satisfy the storage demand. Now, big data rapport. The vertical scaling makes it difficult for SQL databases to store very big data, petabytes. The horizontal scaling and dynamic data schema makes NoSQL suitable for big data. Also, NoSQL databases were developed by top internet companies like Amazon, Google, Yahoo, etc. to face the challenges of the rapidly increasing amount of data. Now, based on properties, we can differentiate as SQL databases use the ACID properties. ACID properties which are where A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability, and these are the ACID properties which are supported by SQL. NoSQL databases, on the other hand, use the CAP, consistency, availability, partition tolerance property. NoSQL databases are generally classified into four main categories. The first one is document database. These databases store data as semi-structured documents such as JSON or XML and can be queried using document-oriented query languages. Key value stores. These databases store data as key value pairs and are optimized for simple and fast read-write operations. Column family stores. These databases store data as column families, which are sets of columns that are treated as a single entity. They are optimized for fast and efficient querying of large amounts of data. Graph databases. These databases store data as nodes and edges and are designed to complex relationships between data. Now, one is SQL database, the other one is NoSQL database. SQL database can be relational and analytical or OLAP. The other one is NoSQL database. NoSQL database is column family, graph, document, and another type is key value. Coming back, let's first get to know about key value pair based. Data is stored in key value pairs. It is designed in such a way to handle lots of data and heavy load. Key value pair storage databases store data as a hash table where each key is unique and the value can be a JSON, blog, comma, string, etc. Binary large objects. It is one of the most basic NoSQL database example. This kind of NoSQL database is used as a collection, dictionaries, associative arrays, etc. Key value stores help the developer to store schema-less data. They work best for shopping cart contents. Redis, Dynamo, React are some NoSQL example of key value stored database. For example, there is a key name. It will hold the value Joe Blogs. Age is a key which contains a value 42. Occupation is a key which contains the value stunt double. Height is a key containing the value 175 centimeter. Weight is a key containing the value 77 kgs. Now column based, column oriented databases work on columns. Every column is treated separately. Values of single column databases are stored contiguously. They deliver high performance on aggregation queries like sum, count, average, min, etc. As the data is readily available in a column, column-based NoSQL databases are widely used to manage data warehouses, business intelligence, CRM, library card catalogs. Now, HBase, Cassandra, HBase, Hypertable are NoSQL query examples of column-based databases. Here, you can see this is a column family. Now, there is a row key, then there is a column name. Column name is holding the values of key value in pairs, right? Now, document-oriented NoSQL database stores and retrieves data as a key value pair, but the value part is stored as a document. The document is stored in JSON or XML formats. The value is understood by the DB and can be queried. Left side rows and columns, and in the right, we have a document database which has a similar structure to JSON. The document type is mostly used for CMS system, blogging platforms, real-time analytics, and e-commerce applications. It should not use for complex transactions which require multiple operations or queries against varying aggregate structures. Amazon, SimpleDB, CouchDB, MongoDB, Ryak, Lotus Notes, MongoDB are popular document-originated DBMS systems. This can be understood by the help of these figures. This figure gives the 4 columns containing different kinds of data. Now, data can be in this format, in a JSON format, right? Now, the first one is prop1 is a key which is holding the value data. Similarly, all 3 documents are doing the same, performing the same operation. Now, graph based A graph type database stores entities as well as the relations amongst those entities. The entity is stored as a node with the relationship as edges. An edge give a relationship between nodes. Every node and edge has a unique identifier. Now, there are three nodes. The first one is city, person, and restaurant. Now, restaurant is located in address, the name of the city. This is the relationship between restaurant and the city, the address. Now, a person has friends. A person is related to itself through his friends. Similarly, person lives in a particular city. That's this edge is explaining the relationship between the person and the city because he is residing in that city. Now, person likes, rates, or reviews that city where he lives. This edge, which is going from person to the city, is also the relationship between person and his city. Now, person likes or dislikes, rates or reviews the restaurant where in that city. Now, the edge going from person to restaurant is a relationship between person and that restaurant. Compared to a relational database where tables are loosely connected, a graph database is a multi-relational in nature. Traversing relationship is fast as they are already captured into the DB and there is no need to calculate them. Graph-based database mostly used for social networks, logistics, spatial data. Neo4j, Infinite Graph, OrientDB, FlockDB are some popular graph-based databases. Now coming to CAP theorem. Like I explained you, there is a huge difference between SQL and non-SQL. SQL supported ACID properties and NoSQL supports CAP. Now what is CAP? CAP theorem is also called Bruce theorem. It states that it is impossible for a distributed data store to offer more than 2 of 3 guarantees. The first one is consistency, second one is availability, third one is partition tolerance. What happens in consistency is that the data should remain consistent even after the execution of an operation. This means once data is written, any future read request should contain the data. For example, after updating the order status, all the clients should be able to see the same data. Okay. Now what happens in availability? The database should always be available and responsive. It should not have any downtime. Partition tolerance. Partition tolerance means that the system should continue to function even if communication among the servers is not stable. For example, the servers can be partitioned into multiple groups which may not communicate with each other. Here, if part of the database is unavailable, other parts are always unaffected. Now, here you can see the CAP theorem. Consistent. Now, there is a RDBMS, there is MongoDB or Zookeeper, and there is HBase master name node with backup RDBMS with failover. Now, RDBMS is consistent. It is not available or partition tolerant. Then there is MongoDB Zookeeper. It is eventually consistent, available and partition tolerant. Then HBase master name node with backup RDBMS with failover. Now, there is A and there is B. A is replicating B. Similarly, read and write operations are being performed in the MongoDB or Zookeeper, right? Now, this is consistency, this is availability, and this is partition tolerance. Example, there is two nodes, S1 and S2. One is at $90, the other one is $100, and there is a third node C. Now, we have to define eventual consistency. The term eventual consistency means to have copies of data on multiple machines to get high availability and scalability. Thus, changes made to any data item on one machine has to be propagated to other replicas. The data replication may not be done instantly, as some copies will be updated immediately while others in due course of time. These copies may be mutually, but in due course of time, they became consistent. Hence the name eventual consistency. Now base is basically available soft state eventual consistency. Basically available means DB is available all the time as per CAP theorem. Soft state means even without an input, the system state may change. Eventual consistency means that the system will become consistent over time. The term eventual consistency means to have copies of data on multiple machines to get high availability and scalability. So this topic will be all for today, and I will be giving you the next lecture on NoSQL advantages and disadvantages. So this will be all for today. Thank you very much.